Hi, my name is Dan Lewis. I'm a materials science and engineering professor at Rensselaer Polytechnic Institute, and today what I'm going to show you is a relationship between the structure and properties of a material. Now this structure, processing, properties triangle that materials engineers use helps us think about the way materials behave in the world. And the material we're going to use today is newspaper, just like this piece I've gotten from the local paper. You can get a piece of newspaper yourself, or you can get a page out of a phone book, something like that, and you could do this demonstration right along with us. Now, paper is manufactured from long-chain cellulose fibers that are derived from plant matter. And in some parts of the world, paper making is a cultural tradition, and those operations are all done by hand. The kind of paper you and I would interact with on most days is made in what's known as a roll-to-roll process. So as the paper moves from one roll to the next, the fibers all align with one another. And that gives the paper some interesting properties in the different directions. So along the fibers, the paper is going to behave one way, and perpendicular to the fibers, it's going to behave a different way. So my helper is going to do the experiment for us, and we'll watch. He's never seen this experiment before, so it'll be interesting to see what his observations are. All right, so we're going to do that demo, and we'll be right back. I used a template to cut sheets of newspaper that were very nearly the same size. I did this for two reasons. I didn't want someone thinking that the shape of the newspaper had something to do with the way it was tearing. And two, I wanted the person tearing the paper to not have an idea of which way the fibers were running. So have you done this demo before?
No.
Do you know what's going to happen?
No.
Okay, all right, let's give it a go. So here's your first sheet of paper. So we're holding it like this, and so what I want you to do is just tear that piece of paper in half. Oh boy, what happened there?
It's hard.
It's hard? Okay, let's try this one. Let me take this sheet here. Tear that one in half, see what happens. Wow. So you may, oh, that's pretty cool. So that one went straight along the edge. Here, try this one again, see what happens. This is a different sheet. Maybe it was just that sheet of paper. Let's see what happens. Yep, just like that. So, okay, so let's use our observational skills here. So I don't know if we can see that. See that? We got two sheets of paper. One of them tears in a straight line, right? Sort of straight down. And the other one looks like it tears a little bit crooked. So what do you think we should do? I don't know. Well, how about we take this little microscope and we attach it to our iPad, and we have a quick look at the microstructure right at the edges of those tears. All right, we'll be right back. So we had a chance to look at the paper under the microscope, and so what did you observe, bud?
Well, the one that was straighter seems to have been less frayed than the one that was crooked, which seems to be more frayed than the one that was straight.
Right. Okay, so one of the things that happens when these newsprint papers are produced is that they're made on what's called a roll-to-roll process. And so as the paper runs along those rolls, the fibers all align in one direction. And so when you tear the paper along the fiber direction, you get a very straight tear, just like this piece right here. But when you try and tear the paper perpendicular to the fiber direction, you get something that looks like this, and it's all crooked and wobbly. And so we can see some of that in the microscope. So when the structure of a material is anisotropic, or its direction is in a particular direction, then its properties are different in those different directions. And a piece of newspaper is a great way to demonstrate this. And so all you need is one sheet of newspaper. What I've done is I've just put a small X on the top there just to keep track of the direction. And of course, the writing on the paper tells you the direction. And so why don't you do it one more time for us? Do you want to do a straight tear, or do you want to do a crooked tear?
Crooked.
Okay, so so for a crooked tear, you want to tear in a direction, fibers are running this way. So which way do you want to tear for a crooked tear?
That way.
Yeah, that's right. Okay, do it. Let's see it one more time. That's right. And now you're just trying your best to tear straight down, right? Mm-hmm. Yeah, okay. Cool. So that's the demo. Simple to do at home. You can use recyclable materials. And thanks for watching. And if you're interested in materials engineering, or you think you want to learn more, just like last time, my contact details are at the end of the video, and we'll see you soon. Thanks.